Assalamualaikum. In today's lecture, we are going to discuss about mesomeric effect. Previously, we have discussed inductive effect that involves sigma bond. Now we are discussing about mesomeric effect that involves pi bond. Mesomeric effect or M effect refers to the polarity produced in a molecule as a result of interaction between pi bonds. Now, you people must understand that this effect only be seen in pi bonds. So, any bonds containing sigma bonds doesn't have mesomeric effect. Okay. This effect is transmitted along in a chain or in a similar way as inductive effect does. Let us consider this example: a carbonyl carbon, a simple carbonyl carbon. This carbonyl carbon has two atoms, one is carbon and the other is oxygen. The oxygen atom is more electronegative than a carbon, so it has a tendency to draw electron away from the carbon atom. As a result, pi electrons in carbon-oxygen double bond get displaced toward the oxygen atom like this. So carbon get positive charge and oxygen get negative charge. Another definition of mesomeric effect is it is defined as decrease in electron density at one position and accompanied by an equivalent increase in density at other position. This is known as mesomeric effect. Let me explain again with this carbonyl carbon example. So this carbonyl carbon and oxygen has positive and negative aspects. So one position decrease electron and in another position it increase electron. Now we discuss about mode of transmission. The mode of transmission of electron takes place in pi bonds. Okay. There are certain rules. Let us discuss the rules. Pi bonds include double and triple bonds. Okay. So for mesomeric effect, system should be unsaturated and conjugated. Unsaturated and conjugated system are those systems that contains alternate double bonds, double or triple bonds. Let us consider this example: CH2 double bond CH, CH double bond CH2. So the transmission of the electrons from one atom to another atom like this. We are having this carbonyl carbon, we are having this CH2 that's transferred to another carbon, and one carbon become positive and one carbon become negative. So the pi bonds or electrons delocalize, so it causes polarization due to decrease or increase electron density at one position accompanied by decrease or increase electron density at other position. So in this position, let us consider another example: CH2 CHCl. Now here involvement of the pi electrons are there. Remember this thing. Okay, there is no electronegativity difference is there. Now we are discussing about positive mesomeric effect groups and negative groups. Chlorine, bromine, fluorine, OH and H2 are considered as positive mesomeric effect group, and negative group considers like COOH, NO2 and carbonyl carbon. These positive M groups donate electron toward carbon atom and causes positive effect, and negative M groups are taking away the electrons from the carbon and causes negative Me. Now consider this example, that is bromobenzene. This bromine contain lone pair of electron, so it has a tendency to delocalize over the entire system one by one. So I have written this example so you people might understand. This is about positive mesomeric effect group. Now consider this negative group effect. So this carbon displays towards another carbon and this carbon displays toward the carbon nitrogen bond. So in a nutshell, one carbon got positive charge and another nitrogen got positive charge. So this is all about mesomeric effect. Thank you very much.